Today we dive deep into the fascinating world of maritime mysteries. Today we have an intriguing topic to discuss, the phenomenon of submarine implosions. So without further ado, let's get started. Before we delve into submarine implosions, let's begin by understanding submarines themselves. Submarines are extraordinary vessels designed to operate beneath the water's surface, exploring the depths of our oceans. They are built to withstand immense pressure, but even the mightiest machines have their limits. Now, let's talk about implosions. In simple terms, an implosion occurs when external pressure becomes greater than the pressure inside an object, causing it to collapse inward. When a submarine dives to extreme depths, the surrounding water exerts immense pressure on its hull. If the pressure differential becomes too great, it can lead to catastrophic consequences. Every submarine has a critical depth known as the crush depth. This is the maximum depth at which a submarine can operate without risking structural failure. The crush depth varies depending on the submarine's design, materials, and construction. Exceeding this depth can spell disaster. To understand this further, let's dive into ocean and see how it feels as we dive deeper and deeper. Humans can swim up to 18 meters underwater without any equipment. The pressure water exerts on us at this depth is nearly 40 pounds per square inch. That cannot hurt a strong person like you. Then let's dive deeper. Let's dive 100 meters deep now. Humans need complete scuba equipment to dive this deep. Pressure here is whopping 145 pounds per square inch. That is some serious damage there. Most people will simply faint. To dive deeper, we need a submarine to help us. Let's dive 500 meters now. That's quite deep, isn't it? Wonder what pressure the submarine has to endure that deep. That's 727 pounds per square inch. You need a really strong submarine to dive any deeper. Let us dive 1,000 meters deep now. The pressure has increased up to 1450 pounds per square inch. Now that's enough pressure to crumble an iron ball. I'm assuming that our submarine is super tough. I'm going to dive 2,000 meters deep now. The pressure has increased to 2,000 pounds per square inch. Let's dive 3,800 meters deep now to see the remains of the great Titanic. Oh, the pressure. It's crushing the metal upon us. Whopping 5,532 pounds per square inch. I wonder if our ship can make it any further. Let's assume that our submarine is indestructible. How far deep do you think we would dive then? The deepest, of course. Let's see if our submarine can take it 11,000 meters deep into the sea. That's the deepest point of our sea. What do you think the pressure would be like here? 16,000 pounds per square inch? That's like a whole building collapsing upon a single point. Another interesting thing about submarines is that most of them cannot be opened by inside. How cruel, right? An innocent person cannot even swim to safety. Well, that's not the case. Even if the person has enough oxygen to travel back to the surface, he won't survive. The moment the hatch is opened, water pressure will instantly kill all the passengers inside the sub. That, too, immensely fast. Therefore, they are better off sealed from the outside. In recent years, implosion survival systems have been developed to enhance crew survivability during submarine accidents. These systems provide a refuge for crew members and are designed to withstand the intense pressures of deep-sea environments until help arrives. As technology advances, so does our ability to design submarines that can withstand greater pressures. Researchers are constantly exploring new materials, construction techniques, and safety features to push the boundaries of what is possible. The future holds promising developments in submarine technology. Thank you for joining me on this fascinating journey into the world of submarine implosions.